Your midterm review, this covers sections 1.1 all the way to 5.5, your last section that was on your last test. The first things that we're going to look at is stating the following, so unions and intersections with these sets of numbers. If we look at 1 through 4, we're told that A is the set of numbers 0, 1, 2, 4, and then B are the set of numbers -2, 0, 2, 4, and then C are the set of numbers 1, 3, 5, and 7. With number 1, we're told to find A union B. Remember, unions, you're including them all. So if you take what's in A and what's in B, it's going to be all of it together. So it's going to be the 0, the 1, the 2, and the 4, with a union of -2, 0, 2, and 4. So remember, these are all of the numbers from least to greatest. So we're going to go -2, 0, 1, 2, and 4. For 2, we have A intersection C. Well, if unions are include them all, intersections are just the ones that are the same. So we said that the set A are the set of numbers 0, 1, 2, and 4. If we find the ones that are the same between that set and C, which is 1, 3, 5, and 7, the only ones that are the same is the 1. So it would just be the 1. For number 3, you have A union B with an intersection of C. We said that from number 1, that A union B is the set of numbers -2, 0, 1, 2, and 4. If we find an intersection with C, which are the numbers 1, 3, 5, and 7, we're telling which are the same between these two parts. So the -2 is not in both, the 0 is not in both. The 1 is in both, 2 is not in both, 4 is not in both. So it's just, again, the 1. For number 4, you have B intersection C with a union of A. Well, B is the set of numbers -2, 0, 2, and 4. With C, we have the set of numbers 1, 3, 5, and 7. So if we want to work with this first, this is just the B union C. So the ones that are the same between both of these is none. So you have an empty set. So you have an empty set with a union of A, which are the numbers 0, 1, 2, and 4. If you have an empty set, which includes no numbers at all, with a union of 0, 1, 2, and 4, it's telling you to include all of the numbers, which are just these numbers 0, 1, 2, and 4. For 5 through 8, our directions just tell us to simplify. So with these, we're working with fractions, adding, subtracting, multiplying, dividing. Remember, with adding, subtracting with these fractions, your denominators have to be the same in order for you to add or subtract them. Once you write like fractions with the same denominators, either add or subtract the numerators, keep the denominator, and simplify. For number 5, you have 3 over 7 plus 5 over 14. Your 3 over 7 and your 5 over 14 share a least common denominator of 14. So that 3 over 7, you have to multiply top and bottom by 2 in order to turn the 7 into a 14. This is going to be rewritten as 6 over 14 plus 5 over 14. From here, add your numerators, keep the denominator. So the 14 stays, 6 plus 5 is 11, so that just gives us 11 over 14. So just like with number 5, for number 6, you're going to find your least common denominator first, but then we have subtraction. So find your least common denominator between the 5 and the 4 for number 6. You have 6 over 5 minus 3 over 4. Your least common denominator is 20. In this case, the 5 has to multiply by 4, which means we multiply the 6 by 4 as well. The 4 would have to multiply by 5, which means we would multiply the 3 by 5 also. So this gets rewritten as 4 times 6 is 24 over 4 times 5 is 20 minus 3 times 5 is 15 over 4 times 5 is 20. Now that you have the same denominators, keep your denominator, which is the 20, and then subtract your numerators. The 24 minus 15, 4 would turn into 14, 2 would turn into 1, 14 minus 5 is 9. From here, you cannot simplify that any further, so that is your answer. For number 7, we are multiplying these two fractions. When you multiply fractions, you can cross simplify if you can, and then multiply straight across. If you do not cross simplify first, you can multiply straight across and then simplify after. For number 7, we have 8 over 11 times 1/4. Now, I like to cross simplify before I multiply, just that way I'm not working with larger numbers. If I do so, the 4 and the 8, since they're diagonal from one another, share a common factor other than 1, which is 4. So you can divide both the 8 and the 4 by 4. The 8 would become 2, the 4 would become 1. So now we just have 2 over 11 times 1 over 1. When you're multiplying fractions, you multiply straight across. So this just gives us 2 over 11. For number 8, you have 3/5 divided by 5 over 2. When you divide two fractions, you want to keep the first one, change to multiplication, then flip the second fraction. So this is going to be rewritten as 3 over 5 times 2 over 5. Check diagonally if you have any like factors between the two numbers. Between the 3 and the 5, your only common factor is 1. Between the 2 and the 5, your only common factor is 1. So multiply straight across. The 3 times 2 is 6, and 5 times 5 is 25. So it's just 6 over 25. Let's go back, because there is some down here. Okay. For these, we are just using our order of operations in order to simplify. For number 9, you have 3 times 7 squared minus 4 plus 8. So our order of operations, PEMDAS, parentheses, exponents, multiplication or division from left to right, then addition or subtraction from left to right. For this one, the first thing that you're going to do is work inside your parentheses. That 7 squared goes first, so that's 49. So it's 3 times 49 minus 4 plus 8. Next, still simplify inside those parentheses. The 49 minus 4 gives us 45, so that's 3 times 45 plus 8. Next, you'll do your multiplication. So the 3 times 45, 3 times 5 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13. So that gives us 135 plus 8. The 5 plus 8 is 13, carry the 1. The 3 plus 1 is 4, and that 1 you drop down. So it's just 143. For number 10, you have 1/4 times 6 minus 4 cubed. Do what's in your parentheses first. The 6 minus 4 is going to give us a negative 2. So that's 1/4 times negative 2 to the third power. Then exponents. The negative 2 to the third power gives us negative 8. So that's 1/4 times negative 8. That negative 8 is the same thing as negative 8 over 1. So you're doing 1/4 times negative 8 over 1. If you want to cross simplify first, you can. The 4 and the negative 8 share a common factor of 4. So 4 divided by 4 is 1. Negative 8 divided by 4 is 2. Multiply straight across, and that just gives you 2 over 1, or 2. So this 2 should be a positive, not a negative. Not a negative. So this would be a positive, this would be a positive, making this a positive. Still giving you the positive 2 for your answer. For our next set of examples, for number 11, we have 5 times 4 minus 15 divided by 3 plus 2. So we are going to look at this using our order of operations. We don't have any parentheses. We don't have any exponents. So we're going to move to multiplication or division from left to right. From left to right, the multiplication comes first. So we'll do the 5 times 4, which is 20. So it's 20 minus 15 divided by 3 plus 2. Next, still go multiplication or division from left to right. You have that negative 15 divided by 3. That gives you a negative 5. So that's 20 minus 5 plus 2. Next, you have addition or subtraction from left to right. So moving from left to right, the subtraction comes first. 20 minus 5 is 15. Then we add the 2 to that, giving us 17. For number 12, you have 7 times 35 divided by 7 plus 2 minus 4. Work inside the parentheses first. Division is going to go first, so the 35 divided by 7 is 5. So that becomes 7 times 5 plus 2 minus 4. Next, work that 5 plus 7, which is 7. So that's 7 times 7 minus 4. Then your multiplication, which gives you 49 minus 4. Then you subtract to have a final answer of 45. For 13 through 15, we are going to use 0 for x, 2 for y, and negative 1 for z to evaluate. For 13, we have 3x plus 7. So this is going to be 3 times 0 plus 7. Multiplication goes first, so 3 times 0 is 0, plus 7 gives us an answer of 7. For 14, you have 3 times y times z minus 2x. So if we plug in those values for x, y, and z, this is going to give us 3 times y, which is 2, times z, which is negative 1, minus 2 times x, which is 0. Start with your multiplication with the 3 times 2. 3 times 2 is 6, times negative 1, minus 2 times 0. The 6 times negative 1 is negative 6, minus 2 times 0 is going to give us negative 6 minus 0, which is negative 6. For number 15, you have 4 times x squared minus 9y. That x is 0, so it's going to be 4 times 0 squared minus 9 times y, which is 2. The 0 squared is 0, so 4 times 0 minus 9 times 2. The 4 times 0 is 0, minus 9 times 2 gives us 0 minus 18, which is just negative 18. For 16 and 17, we're simplifying, so we're just combining like terms with these. So for 16, we have 4xy plus 9x minus 3y plus 6x plus 9y. With these, I like to start from the left and go to the right and simplify by combining like terms. Remember, with your like terms, they have to have the same exact letter and the same exact power in order for them to be like terms. Same variable, same exponent to be like terms. From there, put it in standard form. So it should go from highest power to lowest power from left to right. For 16, if we start with the 4xy, we look for another xy in there. We don't have another xy. We have an x, we have a y, but not together. So that 4xy is just going to be brought down. It doesn't combine with any other like terms. Then we have the 9x, which matches with the 6x. We combine those. 9 plus 6 gives us 15, so it's going to be 15x. Then we have negative 3y and positive 9y. Negative 3 plus 9, or 9 minus 3, gives us a positive 6. We keep the y attached to that. So just 4xy plus 15x plus 6y. For 17, we have 3x squared plus 4x minus 6x squared plus 9x to the 4th power. If I start from the left and move to the right with these terms, if I have anything that matches with the 3x squared, I'm going to combine it. So 3x squared and that negative 6x squared match, so it's going to give us a negative 3x squared. From there, that 4x does not match with another x, so we're just going to drop it down. And then that 9x to the 4th power doesn't match with another x to the 4th power, so we drop it down. This we have to put in standard form. It's not already in standard form for us. So we're going to start with the highest power and work our way to the lowest power from left to right. So our highest power is that 9x to the 4th power. That goes down first. Then the power of 2 would go down, so that's minus 3x squared. And lastly is the 4x. So it's just 9x to the 4th power minus 3x squared plus 4x. For 18 through 21, we're going to solve each of these equations. Remember, you're going to undo addition or subtraction before you undo the multiplication or division. For number 18, you have 9x plus 16 is equal to 88. So we're going to move the 16 over first by subtracting it from each side. We're undoing what we have there, which is addition. So the opposite of addition is subtraction. So we subtract the 16 from each side. That 9x drops down. The 8 minus 6 is 2. 8 minus 1 is 7. So that gives us 9x is equal to 72. From here, that 9x is multiplication. So the opposite of multiplication is division. We're going to divide each side by the 9 in order to get x by itself. It cancels out on the left side, so we just have x is equal to 8. Remember with all of these, for these ones, when you get what a variable is equal to or an answer, you can plug that answer in or substitute that in that answer and see if you get a true statement. If you get a true statement, then that number is definitely your correct answer. For number 19, we have 6x minus 34 is equal to 32. We're going to start this one by adding over our 34. On the left side, those 34s cancel. You drop down your 6x. The 4 plus 2 is 6, and the 3 plus 3 is 6. So that gives us 6x is equal to 66. Divide each side by your 6, and you get that x is equal to 11. For number 20, you're working with an absolute value problem here. So remember, isolate the absolute value, then make yourself two equations. One that is the positive of your answer, one that is the negative of your answer. Remember with these, if you isolate the absolute value and it's equal to a negative number, it is never possible for the absolute value to equal a negative number. So it would be no solution. That's only if you isolate the absolute value and it's equal to a negative number. So for 20, you have 3 times the absolute value of 4x minus 1 is equal to 9. First thing we're going to do here is move the 3 over. It's being multiplied by whatever the absolute value of that 4x minus 1 is. So start by dividing each side by the 3. On the left side, they cancel out, so you have the absolute value of 4x minus 1 is equal to 9 divided by 3, which is 3. Your absolute value is isolated. It is equal to a positive number, so you can continue. We're going to rewrite this as two equations. One that is 4x minus 1 is equal to negative 3, and one that is 4x minus 1 is equal to positive 3. If we work with the one that's on the left here, we're going to first add the 1 over, drop down the 4x, so this gives us 4x is equal to negative 2. From here, divide each side by the 4, and you get that x is equal to negative 2 over 4, which is negative 1/2. This is one of your solutions. Again, with these, same thing as with the 2 that we did before. If you take that, plug it in, and simplify, you'll get a true statement. For the 4x minus 1 is equal to positive 3, you're going to do the same thing. Add the 1 over to begin. Drop down that 4x. So 4x is equal to 4. Then divide each side by the 4. And you get that x is equal to 1. So your two solutions here, you can give as x is equal to negative 1/2 or x is equal, and x is equal to 1. Or you can write it as a solution set of 1/2 and 1. Doesn't matter. For number 21, we have 2 times the absolute value of 4x minus 1 is equal to 6. For this one, we're going to divide each side by the 2 to begin with, just like we did on the one before this. That gives us the absolute value of 4x minus 1 is equal to 3. This is giving you the same exact thing as the one before it. So what are your answers going to be? The same exact thing. Remember, this looks like this, same exact thing. It's going to work out to be the same exact answers. For 22 through 27, we're solving each inequality and we're writing our answer using interval notation. For 22, we have 4x minus 7 is less than 9. So remember, a couple things you need to remember with these. You're still doing the whole undo the addition or subtraction, then undo the multiplication or division. But you need to remember that if you are dividing by a negative or multiplying by a negative on both sides of your inequality, you have to switch the way that inequality sign opens. So for 22, we have 4x minus 7 is less than 9. We're going to start this one by adding the 7 to go to the other side. Cancels out on the left side. The 4x drops down, so it's 4x is less than 16. From here, we're just going to divide each side by the 4, and we get that x is less than 4. If x is less than 4 on a number line, you'd have an open circle on the 4, and your line would go to the left. So from here, if you want to write this in interval notation, look at the way your line runs. It goes to negative infinity. So in your interval notation, it's going to go from negative infinity up to that 4. It does not include that 4, so a parentheses goes on that 4. And then your infinity and negative infinity automatically get the parentheses as well. For 23, we have 6x plus 4 is greater than or equal to 58. For this one, we're going to start by subtracting the 4 from each side. This gives us 6x is greater than or equal to 54. From here, we're just going to divide each side by 6. And we get that x is greater than or equal to 9. So on your number line, if you find your 9, you're going to have a closed circle on that 9, and your line runs to the right. So it goes to positive infinity for this one. Your smallest number that that line includes or goes over is 9. The highest would be infinity. Infinity automatically gets the parentheses. You have a closed circle on 9, so that means you get a bracket on that 9. For 24, we have a compound inequality here with the and. So more than likely, this is going to turn out to where your two lines are going to go in towards each other. So when we do this, we're going to have one interval notation as an intersection. So for this one, we have 3x minus 4 is less than 17, and negative 2x plus 6 is less than or equal to 10. Solving the one on the left first, we're going to move the 14 over by adding it to both sides. That gives us 3x is less than 21. Then we're going to divide each side by the 3, and we get that x is less than 7. For the one on the right, we have negative 2x plus 6 is less than or equal to 10. Move your 6 over, subtract it from each side. So you have negative 2x is less than or equal to 4. Then divide each side by the negative 2. Remember, you're dividing each side by a negative, so you flip your sign. So x is greater than or equal to negative 2. If you look at these two inequalities, the one on the left, that x is less than 7, does not include the smaller number because 7 is greater than negative 2. So I'm going to rewrite these to where that x is greater than or equal to negative 2 is on the left, and the x is less than 7 on the right. When I look at these two arrows or these two inequality signs, they point towards one another now that these are written with the smaller number included on the left. That means that on your number line, on your negative 2 and on your 7 is going to have an open circle, your negative 2 is going to have a closed circle. Those lines are going to connect your two circles, which means for your interval notation, you have a closed circle on negative 2, so you get a bracket on negative 2, comma, 7, open circle on 7, parentheses. For 25, we have negative 6x is greater than 24, or 2x plus 8 is greater than 16. Starting with the one on the left, we're going to divide each side by that negative 6. We flip the sign because we're dividing by a negative on both sides, and that gives us x is less than negative 4. For the 2x plus 8 is greater than 16, we're going to start by subtracting the 8 from each side, and you get 2x is greater than 8. Then you want to divide each side by the 2, so x is greater than 4. On your number line, the negative 4 and the 4 are there. You're going to have open circles on both. Your lines go away from one another. So So that means you're going from negative infinity up to negative 4 with a union from 4 to positive infinity. And both the negative 4 and the positive 4 get parentheses on them because you have open circles. For 26, you have negative 3 times the absolute value of 2x plus 7 is less than 12. So the first thing that we're going to do here is divide each side by that negative 3. Remember, you're dividing each side of an inequality by a negative, so you flip that inequality sign. This gives you the absolute value of 2x plus 7 is greater than negative 4. Evaluate this expression. The absolute value of something is greater than a negative number. This is always going to be true. No matter what, always true. The absolute value of something is always going to be a positive number. The positive number is always greater than a negative number. So since this is always true, your answer for this would be all real numbers, which in interval notation is written from negative infinity to positive infinity. For 27, you have 7 times the absolute value of 3x plus 4 is greater than or equal to 49. First thing we're going to do with this, divide each side by the 7. You have the absolute value of 3x plus 4 is greater than or equal to 7. This is a possibility. Your absolute value is isolated, so turn this into two inequalities. Remember, when you change the sign on that 7, you got to change the way that inequality sign opens as well. So we're going to have 3x plus 4 is less than or equal to negative 7, as well as 3x plus 4 is greater than or equal to positive 7. Working with the one on the left of these, we're going to subtract 4 from both sides. Oops. So this gives us 3x is less than or equal to negative 11. Then we divide each side by the 3. And we get that x is less than or equal to negative 11 over 3. For the 3x plus 4 is greater than or equal to 7, subtract your 4 from both sides. You get 3x is greater than or equal to 3. Then you divide each side by the 3, and you get that x is greater than or equal to 1. If you look at these two, the negative 11 over 3 is less than 1, and it is on the left side. So your two arrows point away from one another. So this is going to be an or statement. So on your number line, the negative 11 over 3 would get a closed circle. The 1 would get a closed circle. And these lines would go away from one another. So it goes from negative infinity up to 11 over 3, negative 11 over 3. It includes the negative 11 over 3, so it gets a bracket. With a union of the 1 includes the 1, so that gets a bracket up to positive infinity. For 28, we are finding the x and y intercepts and writing our answers as ordered pairs. Now, these questions on your midterm will be two separate questions. It won't be both in the same question. You'll have one question that asks you for the x-intercept, one question that asks you for the y-intercept. For number 28, we are given 4x plus 5y is equal to 12. To find your x-intercept, you are going to plug in 0 for y. So this means that we are going to have 4 times x plus 5 times y, which is 0, is equal to 12. If we cancel out that 5 times 0, because it is 0, we just have 4x is equal to 12. From here, we can just divide each side by the 4, and we get that x is 3. So the ordered pair that goes with this is the ordered pair 3, 0. And again, that is your x-intercept. Let's do this color. For your y-intercept, you would plug in 0 for x. So just the opposite. So that would give us 4 times 0 plus 5 times y is equal to 12. The 4 times 0 cancels out, so you have 5y is equal to 12. Divide each side by the 5. And you get that y is 12/5. You cannot simplify that, so put it into an ordered pair, and you have your ordered pair as 0, 12/5. And then again, that one is your y-intercept. For 29, we are given the equation 6x minus 2y is equal to negative 14. For this one, we're going to do the same exact thing. So find our x-intercept. We're plugging in 0 for y. And this will give us 6x minus 2 times 0 is equal to negative 14. The 2 times 0 cancels out, so that's just 6x is equal to negative 14. We divide each side by the 6, and we simplify to get that x is equal to negative 7/3. So that is the ordered pair, negative 7/3, 0. And again, that is your x-intercept.
So we have to simplify it?
Yep, you have to simplify it. For your y-intercept, you're going to plug in 0 for x. So this is going to give us 6 times 0 minus 2y is equal to negative 14. The 6 times 0 cancels out, so we have negative 2y is equal to negative 14. Divide each side by the negative 2, and you get that y is 7. So that's the ordered pair for your y-intercept as 0, 7. For your next set of questions, you're finding the slope for the line that's parallel to this given line. Remember, the parallel line is the same slope. So if we look at these, first put them into slope-intercept form, then find the slope from them. So if we put them into slope-intercept form, we're putting them into y equals mx plus b. For 30, you're given 2x plus 3y is equal to 6. You are going to start by subtracting that 2x from both sides. So that's 3y is equal to negative 2x plus 6. Then you divide each side by the 3. And that gives you y is equal to negative 2/3 x plus 2. Your slope from here is the part that's in front of the x. It's going to stay the same for the line that's parallel to this. So the parallel line's slope is equal to just negative 2/3. For 31, you have negative 5x plus 8y is equal to 17. Again, you're going to do the same thing, solve for y. Put it in slope-intercept form. So this is going to give you the 5x to be moved over by adding it to both sides. So 8y is equal to 5x plus 17. Then we divide each side by the 8. So that's just y is equal to 5/8x plus 17/8. Again, the part that's in front of the x is your slope, so that 5/8 is your slope. Keep it the same for your parallel slope. It's just 5/8. For the lines that are perpendicular, they are going to be the opposite and the reciprocal. So perpendicular lines have opposite and reciprocal. So for 32, we have 3x minus 4y is equal to 15. Again, we're going to solve it for y, put it in slope-intercept form. So move the 3x over, subtract it from both sides. That gives you negative 4y is equal to negative 3x plus 15. Then divide each side by the negative 4. Remember, when you do this, change the sign on everything. So this is going to give you y is equal to 3/4 x minus 15/4. The perpendicular slope, we're going to change the sign of that 3/4. So it's going to be negative, and then we're going to flip the fraction. So negative 4/3 is the slope of the perpendicular line. For number 33, you have negative 5x plus 3y is equal to 12. Move the 5x over, add it to both sides. That gives you 3y is equal to 5x plus 12. Then divide each side by the 3. So this gives you y is equal to 5 over 3x plus 4. Your slope of this line is 5/3. If we take the perpendicular slope, you're going to take the sign that's opposite, so it's going to be negative, and then flip the fraction, negative 3/5. For our next questions, we are stating whether the following graphs represent a function. For 34, 35, and 36, the only thing you have to do is draw a vertical line through the graphs or the lines that are drawn on the coordinate plane for you. If that vertical line intersects once, it's a function. If it intersects more than once, it is not a function. So if we take a vertical line and put it anywhere on the coordinate plane for number 34, we see that this only intersects one time. So this one is a function. For 35, same thing. If you put it anywhere on this coordinate plane, even if you moved it around, it would only intersect one time anywhere you had it. So this one is a function as well. For number 36, again, if you drew that vertical line anywhere on that coordinate plane, you would see that this one intersects twice. So because this intersects twice, this one is not a function. For the next section that we're going to go over, it asks us to state the domain and the range. Your domain are your x values, and your range is your y values from the given ordered pairs. 37, it gives you negative 3, 0, negative 2, 3, negative 1, 6, and 0, 9. For your domain, this is negative 3, negative 2, negative 1, and 0. For your range, it would be your y values. So that's going to be 0, 3, 6, and 9. For 38, you have 4, 2, 8, 4, 12, 6, and 16, 8. Your domain are your x values, so those are going to be the 4, 8, 12, and 16. Your range are your y values, so that's the 2, 4, 6, and 8. For number 39, you're told to find f of negative 5 if f of x is 3x squared minus 4x plus 5. So the only thing we're doing is we're taking that negative 5 and we're plugging it in for x wherever we see an x. So this is going to be f of negative 5 is equal to 3 times negative 5 squared minus 4 times negative 5 plus 5. The 5 squared, or the negative 5 squared, gives us 25, so it's 3 times 25 minus 4 times negative 5 plus 5. From here, you can multiply the 3 times 25 is 75, not 72, 75. Then the negative 4 times negative 5 is a positive 20. So now you have 75 plus 20 plus 5, which is the same thing as 75 plus 25, and that is 100. For 40, you have f of x is equal to negative 6x plus 9, and you're finding f of 4. So we're going to plug in the 4 wherever we see an x. So that's going to be f of 4 is equal to negative 6 times 4 plus 9. The negative 6 times 4 is negative 24, plus 9 gives us negative 15. For number 41, you're using f of x is equal to negative 3x plus 7, and g of x is equal to 5x minus 9. You are finding f plus g of x. So we're finding f plus g of x. We're going to take f of x, which is the negative 3x plus 7, and add it with g of x, which is the 5x minus 9. Because there is subtraction between your two sets of parentheses, you're just going to rewrite this without the parentheses and combine like terms. So that's negative 3x plus 7 plus 5x minus 9. Your like terms here are the negative 3x and the 5x, which give you 2x, and the 7 and the negative 9, which gives you negative 2. So that f plus g of x is just 2x minus 2. For 42, you have f plus g of x, which is the same question as 41. I want you to change it to be f minus g of x. So f minus g of x. So, and then that one is different than 43, which is g minus f of x. So with this one, you are doing f of x minus g of x. So this is the same thing as saying f of x minus g of x. F of x, we said, is the negative 3x plus 7. And then g of x is the 5x minus 9. You have subtraction in between these two sets of parentheses. So distribute the negative into the second set of parentheses. You have negative 3x plus 7 minus 5x plus 9. From here, combine your like terms. So your negative 3x minus 5x is negative 8x. Then you have 7 plus 9, which is positive 16. You'll realize when you do number 43, which is g minus f of x, this is the same thing as saying g of x minus f of x. So you take g of x, which is the 5x, minus 9, and then you subtract your f of x, the negative 3x plus 7 from it. You're still distributing that negative. The only difference is now you're going to have 5x minus 9 plus 3x minus 7. So your 5x and your 3x are like terms. That gives you a positive 8x. Then your negative 9 and your negative 7 are like terms, which gives you a negative 16. So you'll see that these two are opposites of one another. So like your 8x's are opposite, your 16's are opposite. That's because your f and your g switched places. For 44, we are doing f times g of x. So this is the same thing as saying take f of x and multiply it by g of x. So we said that f of x is the negative 3x plus 7, and the g of x is the 5x minus 9. So we're just going to FOIL this out. So the negative 3x times 5x is negative 15x squared. Then the negative 3x times negative 9 is a positive 27x. The 7 times 5 is 35x. And then the 7 times negative 9 is negative 63. You have like terms here with the 27 and the 35x, so combine them. This gives you negative 15x squared. The 5 plus 7 is 12. Keep the x, carry the 1. 3 plus 2 plus 1 is 6. So that's positive 62. Get rid of that. We'll just rewrite it. Plus 62x, and then that minus 63 drops down. So you just have negative 15x squared plus 62x minus 63. For 45, you have f of g of x. So this one's telling you to take the g of x and plug it in for x in f of x. So you're really doing f of g of x is the 5x minus 9. So this just means we're plugging in that 5x minus 9 in for x in f of x, which is the negative 3x plus 7. So this is going to give us negative 3 times x, which is the 5x minus 9 plus 7. We distribute the negative 3 in, so it's going to give us a negative 15x plus 27 plus 7. We combine your like terms, and that gives us the negative 15x plus 34. For 46, we have g of f of x. So we're going to take the f of x now and plug it in for g of x. So we're really doing g of negative 3x plus 7. So f of x is the negative 3x plus 7. We're plugging that in for x in the 5x minus 9. So that's going to be 5 times negative 3x plus 7 minus 9. Distribute your 5. Oops. That's going to give us negative 15x plus 35 minus 9. Your 35 and your negative 9 are like terms, so you combine them to get negative 15x plus 26. For 47 and 48, we're stating whether the ordered pair is a solution. For 47, we're given 3x plus y is equal to 6, and negative 4x plus 2y is equal to 8. The ordered pair we're using is 2, 0. For the 3x, it's going to give us 3 times 2, plus y, that's 0, is equal to 6. For the negative 4, we're going to multiply that by 2, plus 2 times y, which is 0, is equal to 8. We're just going to simplify both of these. So with the one on the left, the 3 times 2 is 6, plus 0 is just 6, is equal to 0. That gives us a true statement. Check the other one, though. The negative 4 times 2 is negative 8, plus 2 times 0 cancels out. Negative 8 is equal to 8. That is not true. So because one of these is not true, they're both not true, it does not give us a true statement at all. So this one is not a function. So they both have to be true in order for it to be a function. If we look at 48, you have 5x minus 3y is equal to 12, and negative 4x plus y is equal to 8. The ordered pair that we're using is negative 2, 8. So our negative 2 is our x, our 8 is our y. This is going to give us 5 times negative 2 minus 3 times 8 is equal to 12, as well as negative 4 times negative 2 plus 8 is equal to 8. For the 5 times negative 2, that's going to give us negative 10. The negative 3 times 8 is negative 24. Negative 10 minus 24 is negative 34. And that is not equal to 12. This should be 12. And then this is 12 as well. So this one is not equal to 12. This one would be no solution as well. Or not a solution. Not a function. So this is your answer for this one. The one before it should have been not a solution. There we go. For numbers 49 and 50, we are using substitution in order to solve. For 49, we have y is equal to 4x plus 2, and negative 5x plus 2y is equal to 11. Since we have a y is equal to, we're going to take that expression and plug it in for y in that second equation and solve for x. So it's going to give us negative 5x plus 2 times y, which the top equation gives us 4x plus 2 is equal to 11. We're going to distribute in that 2, so it's 5x plus 8x plus 4 is equal to 11. Combine your like terms with the 5x and the 8x, that give you 13x plus 4 is equal to 11. You subtract your 4 from each side, you get 13x is equal to 7, and then you divide each side by the 13 to get that x is 7 over 13. You still have to solve for y though.
Isn't the 5 and
Negative.
Yep, it is a negative, so this should be 3, not 13. So this is a 3, not a 13. This is a 3, not a 13. This is a 3, and then this is a 3. This is a 3. So this 5 is negative. There we go. Okay. So still searching for your y. You have y is equal to 4 times x, which we found is 7/3, not 7 over 13, plus 2. The 4 times 7 gives us 28, so that's y is equal to 28 over 3 plus 2. That 2 has to turn into a fraction with 3 in the denominator in order for you to add the 2. So this can be rewritten as y is equal to 28 over 3 plus 6 over 3. So we just add the 2, and we get that y is equal to 34 over 3. Put this as an ordered pair. You have an x of 7/3 and a y of 34/3. So the ordered pair, that's your solution, is 7/3, comma, 34/3. For 50, you have 3x is equal to -9 and 2y minus 5x is equal to 10. You can take that top one of that 3x is equal to -9 and solve it for x. Just divide each side by the 3, and you get that x is equal to -3. From there, plug that into the bottom equation and solve for y. So 2y minus 5 times -3 is equal to 10. The -5 times -3 is positive 15, so that's 2y plus 15 is equal to 10. Subtract each side with the 15. You get 2y is equal to -5. Then divide each side by the 2. So you get that y is -5 over 2. You have your x, you have your y. That means that your solution for this one is -3, comma, -5 halves. (51) gives you 2x plus y is equal to 8, and -3x minus y is equal to 2. We're solving this using elimination. So with this one, we're just going to add these two since our y's are opposites. So if we add, those y's cancel out. The 2x minus 3x is -x, and 8 plus 2 is 10. So from here, if we divide each side by a -1, that x becomes positive, and that 10 becomes negative. So x is equal to -10. From here, you also have to solve for y. So plug this -10 in for x in either of the two equations that you started with. I'm going to use the top since my y is positive there. That's just going to give us 2 times -10 plus y is equal to 8. The 2 times -10 is -20 plus y is equal to 8. You add your 20 over, so y is 28. If your x is -10 and your y is 28, put them together into an ordered pair. That's -10, comma, 28. For 42, you have 4x minus 3y is equal to 6, and -4x plus 3y is equal to 4. So we are going to add these once again because your x values are opposites. So those cancel out. Your 3y's are also opposites, so that leaves you with 0 on the left side. And then 6 plus 4 is 10. 0 is equal to 10 is a false statement. So since this is a false statement, there is no solution for this one. For number 53, you have 5x plus 2y is equal to 12, and 5x minus 4y is equal to 8. For this one, we are going to subtract these two. So your top is going to stay the 5x plus 2y is equal to 12. Your bottom is going to become -5x plus 4y is equal to -8. Remember, subtracting is the same thing as adding the opposites. So now that you have opposite for your x's, those cancel out. The 2y plus 4y is 6y, and the 12 minus 8 is 4. So from here, just divide each side by the 6, and simplify. You have y is equal to 2/3. You're going to take this 2/3 and plug it into either the top or the bottom equation. I'm going to work with the top one. So this is going to be 5x plus 2 times 2/3 is equal to 12. The 2 times 2/3 is 4/3. So this is going to be rewritten as 5x plus 4/3 is equal to 12. That 12 has to also be rewritten so that way you can subtract the 4/3 from it. It has to be something over 3. So 12 is the same thing as 36 over 3. So this gets rewritten again as 5x plus 4/3 is equal to 36 over 3. From here, we're going to move your 4/3 over by subtracting it from both sides. So this is just 5x is equal to 32 over 3. Then we're going to divide each side by the 5. So this turns into x is equal to 32 over 3 times 1 over 5. Because when we divide fractions, we keep change and then flip. We don't have any common factors diagonally, so multiply straight across, and you get that x is equal to 32 over 15. So if we put this into an ordered pair as x comma y, we're going to have 32 over 15 comma 2/3. For 54, we have 8x minus 3y is equal to 2, and 6x plus 3y is equal to 10. We're just going to add these since your y's are opposites. They're going to cancel. Your 6x plus 8x is 14x is equal to 2 plus 10 is 12. We divide each side by the 14, and we get that x is 6 over 7. Use your top or your bottom equation to solve. I'm going to use the bottom one. This is going to give us 6 times 6 over 7 plus 3y is equal to 10. The 6 times 6 over 7 is 36 over 7 plus 3y is equal to 10. That 10 has to turn into something over 7, so it's going to be 36 over 7 plus 3y is equal to 70 over 7. We're going to subtract the 36 over 7 from each side. This gives us 3y is equal to 70 minus 36 gives us 34 over 7. From here, we're going to divide each side by the 3. So again, we're going to keep, change, flip. So y is equal to 34 over 7 times 1 over 3. 3 does not go into 34 evenly, so multiply straight across. This gives you y is equal to 34 over 21. You have an x, you have a y, put it into an ordered pair. This is just 6 over 7, comma 34 over 21. For 55, we have 12x plus 3y is equal to 9, and negative 6x minus 5y is equal to negative 3. We're going to multiply the bottom of this equation by 2 in order to get our x's to be opposites. So the top doesn't change. We're just going to rewrite it. The bottom becomes negative 12x minus 10y is equal to negative 6. We're going to add these two. Since, again, our x terms are opposites, those cancel. The 3y minus 10y is negative 7y, and 9 minus 6 is 3. From here, divide each side by the negative 7, and we get that y is equal to negative 3/7. Plug this into one of the original equations. Now I'm going to use the bottom one, just because we have smaller numbers. We have negative 6x minus 5 times negative 3 over 7 is equal to negative 3. That negative 5 times negative 3 over 7 gives us negative 6x plus 15 over 7 is equal to negative 3. That negative 3, in order to be subtracted or added with that 15 over 7, has to be written as something over 7. So we're going to rewrite this again as negative 6x plus 15 over 7 is equal to negative 21 over 7. From here, subtract your 15 over 7 from each side. This gives us negative 6x is equal to negative 36 over 7. Divide each side by the negative 6. These cancel. You have x is equal to negative 36 over 7 times 1 over, or negative 1 over 6. A negative times a negative is a positive. The 36 becomes 6. The 6 becomes 1. So it's just 6 over 7 for x. If x is 6 over 7 and y is negative 3 over 7, your ordered pair, that's your solution, is 6 over 7, comma, negative 3 over 7. For 56, you have 2x plus 3y is equal to 10, and negative 3x minus 4y is equal to negative 6. for both of these, we're going to turn either your x's into opposites or your y's into opposites. I'd rather work with my x's because my common multiple between the 2 and the -3 is 6, and that's smaller than the common multiple between 3 and 4, which is 12. So we're going to multiply the top equation by 3, bottom equation by 2. This gives us 6x plus 9y is equal to 30, as well as -6x minus 8y is equal to -12. From here, we can just add. Those x's cancel. 9y minus 8y is just y. And you have 30 minus 12, which is 18. From here, plug that 18 into one of the original. I'm just going to use the top one. So it's going to be 2x plus 3 times 18 is equal to 10. That 3 times 18 gives us 54. So this gets rewritten as 2x plus 54 is equal to 10. From here, move your 54 over, subtract it from each side. You get 2x is equal to -44. Then divide each side by the 2. And you have that x is equal to -22. So if x is -22, y is 18. Your ordered pair that is your solution is -22, 18. For your next set of questions, you are just simplifying. For 57, you have 3x to the 4th power times 5x to the 6th power. Your rules with these, multiply your coefficients together. Then if the base is the same, keep the base, add the powers. So we are going to multiply the 3 times the 5, keep the x, add the 4, and the 6. 3 times 5 is 15. X stays. 4 plus 6 is 10. So that's 15x to the 10th power. For 58, you have 4xy squared times 8x cubed y squared. You're going to multiply the 4 times the 8. The x has raised to the first power, so you'll add the 1 plus the 3. The y squared and the y squared, you add your 2's. So this gives us 32, x to the 4th power, y to the 4th power. For 59, you have 12x cubed y squared times 8xy squared z cubed. You're going to do your 12 times your 8. You have x cubed and x to the first power, so add your powers. Then y cubed, or y squared, sorry. Y squared and y squared, so add those powers, and then just a z cubed. So that 12 times 8 is 96. And we have x to the 4th power, y to the 4th power, z cubed. For number 60, you have 3x to the 4th power over 9x squared. You can separate this to be 3 over 9 times x to the 4th over x squared. Let me do this to where it's there. Okay. So with this, that 3 over 9 simplifies to be 1 over 3. That x to the 4th over x squared, your rule is if the base is the same, you subtract your powers. So that becomes x squared. So it's 1/3 times x squared. That squared is positive, so it goes up top on your fraction. So just x squared over 3. For 61, you have 24x to the 5th power y squared over 64x squared y to the 7th power. For this one, you can write it as 24 over 64 times x to the 5th power minus the 2nd power times y squared minus the 7th power. So from here, you can simplify the 24 and the 64 because they are both divisible by 8. 8 goes into 24 3 times. 8 goes into 64 8 times. So that's 3 over 8. The x to the 5th times the x to the 2nd, or, oh my gosh, x to the 5th divided by x to the 2nd is going to give you x cubed if you subtract those powers. And then the y to the 2nd divided by y to the 7th gives you y to the -5th if you subtract those powers. To put these bases that are raised to powers in the proper positions you are going to look at their power. If it's positive, keep it up top. If it's negative, bring it to the bottom. So that x cubed is going to go on top. The y to the fifth goes on the bottom. So it's just 3x cubed over 8 y to the fifth power. For 62, you have 81x to the negative fourth power over 63x to the fifth power, y to the negative second power. For these, you can separate these again. So it's 81 over 63 times x to the negative fourth minus the fifth times y to the second. If you bring that y to the negative second up top, it becomes positive. So from here, the 81 and the 63 are both divisible by 9. So 81 becomes 9, 63 becomes 7. So that's 9 over 7. X to the negative fourth minus the fifth is x to the negative ninth. And then y squared. The negative 9 is going to go to the bottom. The y to the second power goes to the top. So that's 9 y squared over 7 x to the ninth power. For 63, we have 4x squared y to the negative fifth power, all raised to the negative second power. I like to simplify what's inside first. So this inside is going to give me 4x squared over y to the fifth power, all raised to the negative second. Now with this, that negative 2 on the outside has to become positive. So you got to flip the fraction that's on the inside of the fraction, the inside of the parentheses, to turn that negative 2 into a positive 2. So this is just going to give you y to the fifth power over 4x squared, all raised to now the positive second power. That power goes to both the top and the bottom. So y to the fifth power raised to the second power is y to the 10th power, and 4x squared raised to the second power is 16x to the fourth power. All right, so 64, we said that it's 3x to the fourth power y cubed over 8x to the fifth power y squared, all raised to the negative third power. That 3 over 8 doesn't change, so leave it 3 over 8. You have x to the fourth power minus the fifth power, then y to the third power minus the second power, all raised to the negative third power. So with this, you're going to end up with the 3 over 8 x to the negative first, y to the first, all raised to the negative third power. So inside, that x goes to the bottom, the y goes to the top. So it's going to be 3y over 8x, all raised to the negative third power. So we'll flip to make that power, that 3 a positive 3. So just 8x over 3y to the third power. So that 8 to the third power, we said, is 512. X to the third power over 3 to the third power is 27. Y to the third power. For 65, we have 32x to the negative fifth power, y to the second power, over 64x to the negative third power, y to the negative first power, all raised to the fourth power. That 32 over 64, you're going to keep, or you're going to separate. Then you have x to the negative fifth minus the negative third, and y to the second minus the negative first. So that 32 and that 64, they're both divisible by 32. So the 32 becomes 1, the 64 becomes 2. So that's just 1/2. Then you have x to the negative second and y to the third. So your x is going to go to the bottom of your fraction. Your y is going to go to the top. So this is just going to give us y to the third power over 2x to the second power, all raised to the fourth power. We simplify this, a power raised to a power you multiply. So that's y to the 12th power over 16, 2, 4, 8, 16, yes, 16x to the 8th power. For 66, we have 3x squared plus 4x minus 7 plus negative 7x cubed plus 2x squared minus 9x. There's addition between your two parentheses, so just get rid of the parentheses and rewrite this without them. From here, you're just going to combine like terms. So I start with my highest, so that way it's in standard form. My highest power that I have there is the x cubed. You only have that negative 7x cubed, so write that down. Next, you would go with the x squared. So you have a 3x squared and a 2x squared, which give you 5x squared. Next, you have 4x and negative 9x, which give you negative 5x. And lastly, you have that negative 7. So it's just negative 7x cubed plus 5x squared minus 5x minus 7. For 67, you have 3x plus 9 plus 5x minus 4. Again, addition between the two sets of parentheses, so just rewrite it without the parentheses. It's going to have 3x plus 9 plus 5x minus 4. Your like terms here are the 3x and the 5x, which give you 8x, and then the 9 and the negative 4, which give you positive 5. So it's just 8x plus 5. For 68, you have negative 4x cubed plus 6x squared minus 11 minus negative 6x squared plus 4x minus 13. You have a negative between these two parentheses, so you have to distribute that negative into the second set of parentheses. So you're going to change every sign on each of those three terms. This is going to give you negative 4x cubed plus 6x squared minus 11 plus 6x squared minus 4x plus 13. From here, do what you did with the addition, combine like terms. You have a negative 4x cubed. You do not have another x cubed, so just drop that down. Next, you have the 6x squared and the 6x squared, which give you a positive 12x squared. Next, you have the negative 4x, which is just negative 4x. And then the negative 11 plus 13 gives you a positive 2. So it's negative 4x cubed plus 12x squared minus 4x plus 2. For 69, you have negative 3x squared plus 5x minus 7x squared plus 8. Again, negative between the parentheses, distribute the negative, then combine like terms. So it's negative 3x squared plus 5x minus 7x squared minus 8. Your negative 3x squared and your negative 7x squared give you negative 10x squared. Then you have the 5x and the negative 8, which just give you negative 10x squared plus 5x minus 8. For 70, you have 15x squared y cubed times 4xy to the 5th power. That x that's with the 4 has a power of 1. So when you multiply these two, you're going to multiply your coefficients. So you'll do the 15 times the 4. Then you're going to add the powers with the same base. So x squared times x is x to the 2nd plus the 1st. Then x cubed times x to the 5th is, y to the 3rd times y to the 5th is y to the 3rd plus the 5th. So this just gives us 60 x cubed y to the 8th power. For 71, you have 1/3 x to the 5th power y to the 4th power times 12 x to the 4th power y. So that y with the 12 has a power of 1. You're going to do 1/3 times 12, then x to the 5th plus the 4th, and y to the 4th plus the 1st. This gives us 4 x to the 9th power, y to the 5th power. For 72, you have negative 7x squared times 5x to the 4th power plus 9x cubed. So you are just distributing this negative 7x squared in. So you'll do negative 7x squared times 5x to the 4th power, which will give you negative 35x to the 6th power. And then negative 7x squared times 9x cubed, which gives you a negative 63x to the 5th power. So it's just negative 35x to the 6th power minus 63x to the 5th power. For 73, we have 13x times 4x minus 3. So we're just distributing in the 13x. We're going to do 13x times 4x, which is going to give us, the 4 times 3 is 12, carry the 1, 4 times 1 plus 2 plus 1 is 5, so 52x squared. And then the 13x times negative 3 is negative 39x. For For 74, we have 8x to the fifth power times 3x squared minus 7x plus 14. So we're going to do 8x to the fifth power times 3x squared, which gives us 24x to the seventh power. Then 8x to the fifth power times negative 7x squared is negative 56x to the sixth power. And then 8x to the fifth power times 14. The 8 times 4 gives us 32. Carry the 3. 8 times 1 plus 3 is 11. So that's 112x to the fifth power. For 75, we have negative 7x squared times 8x cubed y squared plus 4x squared y minus 5x. So we're going to start with the negative 7x squared times 8x cubed y squared. That's going to give us a negative 56x to the fifth power y squared. Then the negative 7x squared times 4x squared y is going to be negative 28x to the fourth power y. Then negative 7x squared times negative 5x is a positive 35x cubed. For 76, you have 7x squared minus 9 times 4x minus 7y. We're foiling this one. So we're going to do 7x squared times 4x, which is 28x cubed. Then 7x squared times negative 7y is going to be negative 49x squared y. Then the negative 9 times 4x is negative 36x. And negative 9 times negative 7x, I'm sorry, negative 7y is a positive 63y. So just 28x cubed minus 49x squared y minus 36x plus 63y. You don't have any like terms with this, which is why you leave it like this. If you did have like terms, you would just combine them. For number 77, you have x minus 3 times 4x plus 9. We're going to FOIL this one again. So x times 4x is 4x squared. Then x times 9 is 9x. Negative 3 times 4x is negative 12x. And negative 3 times 9 is negative 27. For this one, you do have like terms, so you do need to combine your like terms, which are the 9x and the negative 12x, which gives you a final answer of 4x squared minus 3x minus 27. For 78, you have x minus 1 times 4x squared plus 8x plus 12. So this x is going to get distributed in first, then the negative 1 will, and then you'll combine like terms. So we have x times 4x squared is 4x cubed. Then x times 8x is 8x squared. Then x times 12 is 12x. Then we have the negative 1 times 4x squared is negative 4x squared. Then negative 1 times 8x is negative 8x. This is supposed to have an x on it. Then the negative 1 times 12 is negative 12. So from here, you're just combining like terms. So you have 4x cubed plus 4x squared plus 4x minus 12. For number 79, you have 2x plus 3 times 5x squared plus 7x minus 6. First, distribute the 2 in. So 2x times 5x squared is 10x cubed. Then 2x times 7x is 14x squared. The 2x times negative 6 is negative 12x. Then you'll distribute the 3 in. So 3 times 15x squared, 5x squared is 15x squared. 3 times 7x is 21x. 3 times negative 6 is negative 18. From here, combine your like terms. So it gives you 10x cubed plus 29x squared. That negative 12x plus 21x, you're going to subtract those and keep the sign of the bigger number. Bigger number is positive. The 1 turns into an 11. The 2 turns into a 1, so 11 minus 2 is 9x. And then that 18 drops down. So it's just 10x cubed plus 29x squared plus 9x minus 18. For number 80, you have 3x plus 1 to the second power. This is a binomial squared. So we are going to find our a, which is the 3x, find our b, which is the 1. We see that we have addition between the two terms. So we're going to use the formula a squared plus 2 times a times b plus b squared. Plug these in and simplify. So we have 3x to the second power plus 2 times 3x times 1 plus 1 to the second power. So this just gives us 9x squared plus 6x plus 1. If you don't like doing it this way, you can expand it to be the 3x plus 1 times 3x plus 1 and just FOIL it out. You're going to get the same exact thing. For 81, you're going to do the same thing that you did for 80. So you have a plus b to the second power. Your a is the x, your b is the 7. There is addition between the two. So again, we'll use the a squared plus 2 times a times b plus b squared. So we plug in our values. So that's x squared plus 2 times x times 7 plus 7 squared. So this just gives us a final answer of x squared plus 14x plus 49. For 82, you have 5x minus 6 raised to the second power. So that 5x is going to be our a. Our 6 is going to be our b. We have a negative between these two terms now. So we're going to use a squared minus 2 times a times b plus b squared. So this is going to give us 5x to the second power minus 2 times 5x times 6 plus 6 to the second power. That 5x to the second power is 25x squared minus 2 times 5x is 10x plus times 6 is 60x plus 6 squared is 36. For 83, you have 10x minus 3 to the second power. Same thing that we did in the last one. Your a is the 10x, your b is the 3. Subtraction separates the two, so we'll use a squared minus 2 times a times b plus b squared. So this is just going to give us 10x to the second power minus 2 times 10x times 3 plus 3 to the second power. The 10x to the second power is 100x squared minus 20x times 3 is 60x plus 9. For 84, you have 7x plus 13 times 7x minus 13. You have a difference of squares here because your two sets of parentheses have the same terms, but their sign in between separates them. The sign that in between them that separates them are opposites. So because you have opposite signs and your a is the same in both, which is the 7x, your b is the same in both, which is 13, you are going to use a squared minus b squared. So this is just going to give us 7x to the second power minus 13 to the second power. The 7x to the second power is 49x squared. The 13 to the second power is 169. So that's just 49x squared minus 169. For number 85, you have x minus 3t times x plus 3t. This should be 3t, not 3y. So let's change this to be 3t. Okay, so now that your two binomials have the same a and the same b, and they're separated by opposite signs, you're going to use a squared minus b squared. And again, your a is the first term, which is going to be x. Your b is the second term in both, so that's going to be the 3t. So this is going to give us x to the second power minus 3t to the second power. So it's just x squared minus 9t squared. For 86 through 100, you are just factoring completely. So for 86, you have 12x squared y squared minus 9x cubed y cubed plus 27xy cubed. You're going to try to factor out the greatest common factor from this. They are all divisible by 3. So that's going to be your number term that you're factoring out. They have all an x. The smallest power is 1, so we'll factor out an x. They all have a y. The smallest power is squared, so we'll factor out a y squared. Remember with this, what you are dividing each term by goes in front of whatever's left over. It doesn't just disappear. So this is going to give us 3xy squared times 4x minus 3x squared y plus 9y. From here, ask yourself if you can simplify this any further. You can't, so this is your answer. For 87, you have 16x cubed plus 28y squared minus 12xy plus 4x. You have a greatest common factor out of all of these, which is 4. So we'll start by factoring out the 4. This is going to give you 4 times 4x cubed plus 7y squared minus 3xy plus 1x, or just x. From here, even if you tried to rearrange your terms, even though and you have 4 terms, you cannot factor by grouping, so you leave this as your answer. For 88, you have 20x squared plus 5x minus 28x minus 7. Key indicator here, you do not have any like terms. They're not all even numbers. They're not all divisible by 5. They're not all divisible by 7. So you have 4 terms. Try to factor by grouping. Group the first 2, group the last 2. Factor out the greatest common factor from both. From the 20x squared plus 5x, your greatest common factor is a positive 5x. From the negative 28x minus 7, your greatest common factor is negative 7. So this can get rewritten as 5x times 4x plus 1 minus 7 times 4x plus 1. Your 2 sets of parentheses that you have are identical to one another, so you'll rewrite the 4x plus 1 once, and then form another with the 5x and the minus 7. So you just have 4x plus 1 times 5x minus 7. For 89, we're going to do the same thing. So we have 6x squared minus 27x plus 8xy minus 36y. We're going to group the first 2 terms. We're going to group the last 2 terms. From the first 2 terms, we can factor out a 3x. From the last 2 terms, we can factor out a 4y. This is going to leave us with 3x times 2x minus 9 plus 4y times 2x minus 9. Your 2 sets of parentheses are identical, so this is going to leave us again with 2x minus 9 times 3x plus 4y. For 90, you have 169y squared minus 64. You can take the square root of the first term, you can take the square root of the last time, and there's a negative that separates them. So factor this using the difference of squares. You can do the square root of 169y squared, which is 13y, and the square root of 64 is 8. So this is going to just give you 13y minus 8 times 13y plus 8. For 91, you have 4x squared minus 49x squared minus 4y squared. You can take the square root of the 49x squared, that's 7x. You can take the square root of the 4y squared, that's 2y. There's subtraction between the 2, so this ends up becoming 7x minus 2y times 7x plus 2y. For 92, you have 16x squared plus 24x plus 9. You can take the square root of that 16x squared, it's 4x. You can take the square root of that 9, it's 3. If you did a positive 2, because that 24 is positive, times 4x times 3, it gives you the positive 24x, which is your middle term. So use the formula a plus b to the second power. We said your a is the square root of 16x squared, which is 4x, plus your b, which is the square root of 9, is 3, gives us 4x plus 3 raised to the second power. For 93, you have 9x squared plus 30xy plus 25y squared. Again, take the square root of the 9x squared, that's 3x. Take the square root of the 25y squared, that's 5y. If we do a positive 2 times 3x times 5y, it gives us 30xy. That is your middle term. So we're going to use a plus b to the second power. Your a is the 3x plus your b, which is the 5y, is raised to the second power. For 94, you have x squared minus 6x plus 9. You can take the square root of that x squared, it's x. You can take the square root of the 9, it's 3. The sign between them is negative, so if we do a negative 2 times x times 3, it gives us the negative 6x. That is our middle term. So for this one, since it's negative, we're going to use a minus b squared. So this is just x minus 3 to the second power. For 95, you have 4x squared minus 12xy plus 9y squared. So we're going to take the square root of that 4x squared, it's 2x. Square root of 9y squared is 3y. Sign in the middle is negative. So if we do negative 2 times 2x times 3y, it gives us the negative 12xy, which is that middle term. So we're just going to have 2x minus 3y squared. For 96, we have 24x squared minus 6x. We're going to factor out the greatest common factor between these, which is 6x. And this is just going to leave us with 6x times 4x minus 1. You cannot do anything else with this, so that is your answer. For 97, you have negative 27x to the fourth power plus 12x squared. You're going to factor out your greatest common factor here, which is going to be negative 3x squared. This is going to leave us with negative 3x squared times 9x squared minus 4. You have a difference of squares in that set of parentheses. So take the square root of for the first term, take the square root of the second term. You have 3x and 2 separated by a negative. So this is going to factor fully to be negative 3x squared times 3x minus 2 times 3x plus 2. You have to remember with these to factor completely. For 98, you have 18x cubed y plus 24x squared y squared plus 8xy cubed. Your greatest common factor between all three of these terms, you're going to start with a 2, then they all have an x and they all have a y. So this is going to factor out to be 2xy times 9x squared plus 12xy plus 4y squared. You can take the square root of the 9x squared. You can take the square root of the 4y squared. 2 times 3x times 2y gives you the 12xy up top there in the middle. So this is going to factor fully to be 2xy times 3x plus 2y squared. For number 99, you have negative 196x cubed plus 336x squared minus 144x. I'm going to start by dividing these by a negative 4x, and that goes outside. This is going to leave me with a positive 49x squared. The 336 divided by negative 4 is going to be a negative 84x. And then that 144 divided by 4 is 36. So from here, you can take the square root of the 49x squared. You can also take the square root of the 36. It's 7x and 6. So if we did 2 times 7x times 6, that gives us the negative 2x. So this is just going to become negative 4x times 7x minus 6 squared. For our last question, number 100, you have 27x cubed plus 90x squared y plus 75xy squared. You're going to factor out a 3x from all of this, and this is going to leave us with 3x times 9x squared plus 30xy plus 25y squared. You have a perfect square trinomial here. Take the square root of the 9x squared, that's 3x. Take the square root of the 25y squared, that's 5y. If you did a positive 2 times 3x times 5y, that gives us the 30xy. So this factors out fully to be 3x times 3x plus 5y to the second power.